I want to talk about interpreting slopes as a rate of change. So what I've drawn here is a graph with a bunch of ordered pairs. In fact, we can label some of these. This looks like it's 3, 5 halves. This is 6. Let's use decimals here. Let's see. 3, 2.5, 6, 7.5. This is 9, 20. And this is 12, 15. Something like that. And I guess this would be 15, 15. And what this graph represents is, we can see here, it looks like, for some reason we have a little home drawn here. This is the origin. This is not the x-axis, but in this case the t-axis, and it says it's measured in hours. And this is the d-axis, and it says it's measured in miles. And the problem says a person leaves home and begins walking. The graph shows the distance d in miles the person is from home. T hours after leaving home. For each of the following t values, find the slope at that location and interpret your results. And the first one here is t equals 2. All right, well, let's see. Let's get a different color here. This is where t equals 2, and this is the point on that line. And this line segment right here has a certain slope. So let's call that slope 1. And although it's at t equals 2, I can use the endpoints of that line to calculate the slope. So let's see, this is the point 0, 0 at home, meaning at time 0 we've gone 0 miles from home. And at time 3 we've gone 2.5 miles from home. And the slope 1 here is going to be the change in y over the change in x, or in this case, the change in the distance over the change in the time, since d is acting like the y value and t is acting like the x value. So this will be d2 minus d1 over t2 minus t1, which in this case is, let's see, 2.5 minus 0 over 3 minus 0, which is 2.5 over 3, which is 5 over 6. Let me just write that as 5 over 6, which is this approximately, let's see, let's round that off. If we run that through our calculator, 5 divided by 6, we're going to get 0.83 bar, repeating 0.83333333. So it's approximately 0.83. But what's important here, besides the number, is the units, and that's what I want everybody to pay attention to in this example. When we calculated this numerator, it was a distance minus a distance. It was 2.5 miles minus 0 miles. So the units in the top are miles, and the units in the denominator are hours. And so what this is it's a rate of change. It's not just the number 0.83, it's in the context of these units. It's actually in miles per hour. And so we can interpret this as 2 hours after leaving home, the person is walking at a rate of 0.83 miles per hour. Sometimes we say mph, when what we really mean is miles per hour, using this fraction notation. So let's try it again. The next one is t equals 5. Let's see. for t equals, oops, let's get a different color. For t, well, different color than that. Okay. For t equals 5, that's this point here, so we can use this point and this point to get the slope of that line. And that's going to be hard to look at here. I'm just going to go back to black here. So this is going to be 7 point, the slope 2 is going to be 7.5 minus 2.5, the difference in the d values, over the difference in the t values, 6 minus 3, which is 5/3. Now, 5/3 is about 1.6 bar. This is in miles per hour again. Let's make sure everybody can read that, actually. Miles per hour, which is approximately 1.6 miles per hour. And so we might say something like 5 hours. Why 5 hours? Because we're doing this at t equals 5, right? 5 hours after leaving home, the person is walking at a rate of 1.6 miles per hour, roughly. It's an approximation. Okay, let's keep going. So what happened there? Well, the person picked up speed from the first 3 hours to the second set of 3 hours. From the first 3 hours, 0 to 3, looks like they were walking at an average of about 0.83 miles per hour, a little bit less than 1 mile per hour, which is a pretty slow pace. And then they start walking at about 1.6 miles per hour, almost 2 miles per hour, which I think is about a pretty average pace to walk at. But you'll notice here in the next interval, for when t is equal to 8, things get a bit steeper. So for M3, we'll use the endpoints here. And that is, again, going to be, let's see, M3 is the change in the d values, which is 20 minus 7.5 divided by 9 minus 6, which is 12.5 over 3 miles per hour, meaning that in 3 miles they covered, in about 3 hours they covered 12.5 miles, or on average they covered about 4.16 miles per hour. So this seems to be about maybe a jog, a slow jog. And so let's see here. Let's cut to the chase. Duplicate. And you'll notice this is just some cookie cutter stuff. Let's see, 8 hours after leaving home, the person is walking at a rate of 4.16 miles per hour. It's probably more like a jog than a walk, but some people walk fast, man. Okay, our next one is at t equals 10. So let's say t equals 10 is here. And now there's really a drastic change. This is going to be slope 4. And we'll use these 2 points, 12, 15, and 9, 20. And what we get is slope 4 is equal to 15 minus 20 over 12 minus 9, which is negative 5/3 miles per hour. What does that mean? Well, that's approximately negative 1.6 miles per hour. How do you walk at a negative speed? Well, you don't. What that means is its direction. So as these slopes were going up and up and up, we were getting further from home. But now we're getting closer to home. That is to say, it's not just distance, it is miles per hour towards home. So maybe we should have said that in each one of these. That is to say, in the first one, since it's positive, 2 hours after leaving home, the person is walking at a rate of 0.83 miles per hour away from home. Away from home. Away from home. So what's going on there is the distance from home is increasing because that difference was positive. Whereas in this one, let's see if I can just cut and paste this. Let's see, duplicate. I don't know if I'll be able to fit it in here. So let's see, this time, 10 hours after leaving home, the person is walking at a rate of 1.6 miles an hour, but not, and you notice I dropped the sign there, but I'm going to interpret that as toward home. So this is going back. And then at t equals 13, this is getting messy, 13, we're going to use these 2 points, and so this is just, maybe we can just eyeball this one. That's M5, that's a horizontal line, and this is going to be M5 is equal to 15 minus 15 over 15 minus 12, which is 0 over 3, which is 0 miles per hour. So 0 miles per hour. The person has stopped walking. So there you have it. That's just an interpretation of what's going on in this graph by calculating the slopes. And out of everything that we've done in the video, this might be the technique or the problem that uses all of our techniques at once, being able to interpret what we're seeing. Looking at these numerical values and not just seeing them as a number, but interpreting them in the context of the problem. So what were the key things here? You got to be able to calculate a slope, and then you got to be able to interpret it.